In this video for Positive Maths, we're going to go through the proof of Theorem 14. So we want to prove the theorem of Pythagoras. We're given a right angle triangle, ABC. We want to prove that the side BC squared is equal to AB squared plus AC squared. Our construction. We draw a perpendicular line from A down to BC. This creates two new triangles. Our perpendicular line AD creates the triangle ABD and ADC. So we've just shaded these in yellow and green so we can distinguish between the two. We're also labeling our angles. So the angle at B we've labelled 1. The angle BAD is 3. DAC is 4. And ACD is 2. So we want to consider these three triangles. So we have our first triangle ABC. Now we have our smaller triangle ABD. And we have the triangle ADC. We're going to notice because AD is perpendicular to BC that we now have three right angled triangles. So the proof. First of all, we're going to consider the angles ABC and ABD. So this is the main big triangle and one of the smaller triangles. Angle 1 is common to both. The angle BAC is equal to the angle ADB, so they're both equal to 90 degrees. Therefore, the triangles ABC and ABD are similar, because if they have two angles that are equal, then the angle 2 is equal to the angle 3, because they all have to add up to be 180 degrees. So therefore, the two triangles are similar. If the angles are similar, then we can say that BC, so the hypotenuse of the big triangle over the hypotenuse of the small triangle, is equal to AB over BD. So therefore, AB squared is equal to BC multiplied by BD. So what we did here was we cross multiplied to get from here to here. So we multiplied BC by BD is equal to AB multiplied by AB. And that's what gives us the following line. So we're going to call this equation now equation number 1. So AB squared is equal to BC multiplied by BD. Now we're going to consider the triangles ABC and ADC. So this time, again, we're taking the main triangle that we started with, ABC, and we're now looking at the green triangle ADC. Angle 2 is common to both triangles. The angle BAC is equal to the angle ADC, so they're both equal to 90 degrees. And therefore, the angle 1 is equal to the angle 4. So the triangles ABC and ADC are similar. So we can therefore say again, the side AC over the side DC is equal to the side BC, so again the hypotenuse of the bigger triangle, over the side AC. Therefore again, when we cross multiply again, we'll get the following line. So AC squared is equal to BC multiplied by DC. And this is our second equation. So the next step is to add 1 and 2. So the reason why we're going to add 1 and 2 is that if you recall on the first slide, we want to show that BC squared is equal to AB squared plus AC squared. So we have AB squared and we have AC squared, so that's from our formula 1 and from our formula number 2. So if we add these together, we want to show that the sum of the two equations will give us BC squared. So AB squared plus AC squared is equal to BC multiplied by BD plus BC multiplied by DC. In the next line, we're going to simplify by taking out the common term. So that's BC. So we get BC multiplied by BD plus DC. So BD plus DC is equal to BC. So that's because, if we recall again, our very first triangle that we started off with. We have ABC. We constructed perpendicular line, and this was D. So BD plus DC is equal to BC. So that's where we're getting that from. Therefore, we've shown that AB squared plus AC squared is equal to BC squared. For more information, visit PositiveMaths.ie, email us at info@PositiveMaths.ie, and follow us on Facebook and Twitter. Thanks for watching.